Hi. Mm, this video you're going to start with Turing machine construction, which will be very interesting. It is more or less equivalent to writing a programming. But here instead of writing a programming, you'll be writing transition function, or you'll be representing the corresponding Turing machine with the transition diagram. So here also you can represent a Turing machine either with a table or with a diagram, right? So we'll start with very basic and simple example. Here we are going to construct a Turing machine for the language L is equal to A bar and B bar N. So we know that what is the meaning of this language? That is, this language is made up of the symbols of A's and B's, and with the constraint that it begins with A and followed by B, and we have to check whether, that is, we have to accept this language only if the number of A's followed by the number of B's are equivalent. So just let me recall uh, the basic structure of a Turing machine. This Turing machine, as usual, consists of a set of states, and unlike PDA, here we store the input in the storage medium of the Turing machine itself. What is the storage medium of this Turing machine? It is nothing but a tape of size infinite length, right? So here you will be storing the input string in the tape itself, and you will be processing. And along with processing the input symbol, you have to move the tape head, which the Turing machine consists either left or right. So by you have to move either left or right, and you cannot miss that, right? So keeping this in mind, we'll go in detail about the construction of a Turing machine. So assume this is an infinite tape. So I have not drawn the finite control, just we'll take only the storage, right? So for instance, here I have taken n is equal to 4. So we know that it consists of, by default, each cell of the Turing machine contains blank symbol. Wherever you want to store, you can store, as we indicated in the instantaneous description. So we'll be concentrating only upon the symbols between the two blanks. That is, we'll be concentrating only on the input symbol, right? So always the Turing machine starts to process from the leftmost input symbol, whatever it may be. It starts its processing from the leftmost input symbol, and it goes one by one. So depending upon the direction in which it is asked to move, it can move either left or right. Okay. So before that, we have to think about the logic. What, that is the methodology that we are going to use for checking whether the number of occurrences of A is equivalent to the number of occurrences of B, right? So here in PDA, we did this by storing A in stack, then by popping 1A for every B that I scan in the second part. So what about the Turing machine? I have only one medium, that is T. So here, first of all, I'll check 1A, and for every A that I check here, I move towards right and check for an equivalent B. I'll be repeating the process until I have only until all the A's and B's are processed, right? So in order to differentiate between the visited and unvisited A, I can either change that A to B. It depends. It's our wish. So here I'm going to change A as X. That is, when I visit a particular A, I'm going to cross. That is, change that A as X. And I'm going to move towards right. And if I scan a B, that will be changed to Y. Again, I will come back towards left and near to the A, that is near to the A, near to X. By changing A to X, again I will be repeating the process until A's and B's are checked. So here, let Q be the starting state. And as I already told you that Q will be always pointing to the leftmost symbol present in your tape. So here it is pointing to the leftmost symbol. So I can represent this like this. So transition of Q comma A. So what we decided, so whenever I scan an A at first, I'll change that A to X. And I'll be moving towards right. Why I have to move towards right? Because the value B value is present only in the right side of A. So I am moving in the right direction. So here I am making use of R for representing the right side move. Sometimes in some textbook they make use of right-headed arrow mark to represent the right side move, right? So what I want to replace, A has to be replaced by X. I'm repeating again, it is not compulsory that A has to be replaced only by X. It depends upon your wish. So whatever symbol you want to replace, you can replace that, right? So Q, I am assuming it as a starting state. Here also you can assume whatever state you wish. So Q comma A. So what I am going to do, I am going to change A as X. So whenever I am making any changes, that is making some changes to the symbol, I am making a transition. Again, it is not compulsory. If you want to remain in the same state, it can be in the same state itself. Now A is replaced by X and the tape head moves towards right. So when I say towards right, it moves only one position in the cell. So like this. So A is replaced by X and the state Q becomes P, and the pointer from here has moved towards one cell toward the right. So now what is my next target? For every A, I have to check an equivalent B for in the right direction. So whatever or how many number of A's I scan, in between I need not worry about it, because I have already checked one A. Now my target is checking one B, right? So if it scans now P, if it scans A, it just skips and moves towards right until it scans a B. So like this. So okay, before going into this, since our transition is usually the Turing machine consists of large number of transitions. Here I'll make use of a transition table, right? So here this transition is represented like this. Since Q is a starting state, I am representing with an arrow mark. The input symbol is A. Now Q, when it scans A, what I'm doing, I'm replacing A by X and moving to another state, say P, and the tape head is moved towards right. So like this transition function is equivalently represented like this in the transition table. So what we decided, so in the previous line, after making A as X, it has moved one cell towards right. So now, so my target is scanning B. I'm not going to do anything with A. So whatever how many that is independent of the number of instance of the A, I'll skip all those A's. So whenever I scan A, that is the state P scans A, it simply replaces A by A, because I'm not going to, my target is to scan only B. So it keep on moving using this condition itself. So now the state P is scanning B. So what we decided, whenever I scan one B equivalent to a checked A, that B has to be replaced by Y. So here I am deciding like that. If you want to change, you can change with another symbol too. So I'll add one more column for the input symbol, say B, and I'm going to replace B by Y, right? So now since I'm replacing the input symbol by some other symbol, I'm making transition to another state. Since I verified one symbol, 1B, my next target is to go towards left and check this A, which is adjacent to X. Already checked A, right? So I am moving in left direction. I am repeating again. So my target is, my logic is, first for every A that you scan, you just check mark it. In order to differentiate between checked and unchecked A, I am converting whatever A that I am scanning or currently processing, I am converting that A to X. So after that, so for that A, I have to find an equivalent B in the right hand side. Why I am very sure that B will be present only in the right hand side? Because my input language is like this. That is, it is of the form A par n, B par n. So I am moving towards right. In between, I can scan or I will be scanning any number of A's. So I need not worry about it. Well, if I scan A, just I'll skip and I'll move towards right. Whenever I scan a B, I'll stop there. I'm replacing that B by Y. So now for that A, which we scanned here, I have found an equivalent B, right? So now my target is to find a next A. So you may ask me why you have to find or you have to check the A that is adjacent to crossed A, previously crossed A. because in between also you can cross, but you'll not be able to keep track of the check done and checked A. So suppose if I am replacing this A by X randomly, if I am replacing means, then I'll not be able to track whether I've checked all the A's after this X or before the X. So in order to avoid those confusions, I'll go back and check the A nearest to the already verified A's, right? So now the target of R is moving towards left until it scans X. So it is not going to replace anything. Just it is going to skip all A's. Its target, the target of this state R is to find an X that is checked A. So it is moving. So it is whenever it scans A, it simply moves towards left. So we know that always it will be scanning a right symbol wherever it is present. So now it is scanning X. So what you have to do, I have to repeat the process. What process should I must repeat? You have to convert A to, that is you have to change A to X. Then you have to move towards right. Scan 1B, convert 1B to Y. Again you have to come back. We have already done this process. Where this process starts, it starts from the state Q. So now R, whenever it scans X, it means that it has to repeat the process already done by the state Q. So instead of writing it instead of repeating it again here, it makes transition to the state Q itself, right? So X, I'm not going to replace X by X, just it is moving towards right, and the state goes to Q. Now Q takes care of it because Q know what it has to do when it scans an input symbol A. So now it again replaces Q again scans A. It again replaces A by X, moves to the state P, and its next target is to find a uncrossed B. So it moves towards right, and the process repeats. So now it has replaced A by X, and it is moving towards. But while it moving, previously it has not scanned Y, but now it is scanning a new symbol, say Y. So that's why I have assumed n is equal to 4. If you have taken n is equal to 2, you might not encounter all these cases. We will be missing few cases. So whenever you take value for n, you take it at least 3, so that you will not miss any of these cases in the transition table. And one more important thing, kindly do not memorize whatever I say here. Right? You just understand, you draw, you take some value for n with minimum 3, and you try to fill this table by yourself. Then only sometimes they will ask different Turing machine which we have not studied in the textbook or in our classwork. So in that case, when you train like this only, you will be able to observe and you will be able to write something in your examinations. Right? So it is scanning Y. So I am including one more column, say Y. So Y is not the target of P. The target of P is the input symbol B. So it just skips it and moves towards right. Later it scans B. Now automatically this B will be converted to Y, and it moves to the state R. Again the state R moves towards left until it scans on X. So with this X it starts. Again it moves to the state Q, which converts this A to X, and the process repeats. So finally, after crossing this, it again comes back. It doesn't know that it has crossed all A's and B's, so it comes back. So the state R, after scanning X, it again changes to Q, but Q now does not find any A because we have crossed all A's and all A's. But I should not conclude with this. Why? Because sometimes the number of A's might not be equivalent to number of B's. So I have to move towards right. So until otherwise, that is move towards right, if I scan only Y. Right? So keep it in the following point. You have to remember that we will be writing transition function only for the correct solution. We will not be considering the wrong cases. Okay, so I'll be moving towards right. I'll be keep on moving towards right. So whatever I scan, it is not that I'll here for the correct expression, I'll be scanning only Y. Right? So Y